enseguida dónde va a estar eso. Entonces, la primera observación, entonces la clase va a ser en inglés. Les pedimos que hagan su mejor esfuerzo, digamos, y en principio una regla general es no se permite el español, salvo que la palabra que se deba usar está en español y que hagan su mejor esfuerzo por hacerse comunicar en inglés. ¿Listo? Esto es pensando en que de pronto ustedes puedan estar en un ambiente con nativos de habla inglesa o alguien que solamente pueda comunicarse en inglés para que ustedes aprendan cómo es que se comunica uno ahí. Un disclaimer, una advertencia es, nosotros no somos nativos, entonces vamos a contar con nuestro acento, pero hacemos pues nuestro mejor esfuerzo ahí y también después lo que vamos a notar es que la clase se vuelve una clase normal, digamos. A veces el vocabulario a uno le falta, pero por ahí entre ustedes mismos, entre todos nos ayudamos para de pronto alguna palabra que no conozcamos. Es muy importante. También otra de pronto recomendación es, algunos estudiantes hemos notado, pronto al comienzo se puede permitir, o ustedes pueden usar algún transcriptor de estos que hace la generación de los subtítulos para como de pronto no perderse, pero la recomendación es que después si los pueden usar preferiblemente al comienzo y después ya dejen de usarlo para no generar esa dependencia. Bueno, entonces ahora sí. Entonces estamos hoy, el profesor Fabio tal vez no está hoy con nosotros, pero va a estar con seguridad. Profesor Fabio, si está, grite, no está. Entonces vamos a estar los tres profesores a cargo del curso, profesor Alfonso Meléndez de la Universidad Escuela Colombiana de Ingeniería, el profesor Fabio González y yo de la Universidad Nacional de Colombia. Okay, so now it's time to switch to English. So today we are going to to introduce the class. So we're going to present the syllabus. So what are the goals, so the objectives of the class, and then what is going to be the methodology that we're going to use in the class, how we are going to evaluate, and of course, some references, the contents of the class, and we will also state some rules. We're also going to set some rules about how you should behave. You need to behave in this class. Okay, so let's get started then. So before I get started with the program, I don't know if Professor, you want to maybe address the students, maybe say a few words before we go, you know, on the syllabus of the class.
Gracias Luis Fernando. Voy a hablar en español unos minutos también y después hablaré en inglés. Esta es la segunda versión de un curso que estamos dictando en convenio con la Universidad Nacional. Es un curso de ciencia de redes. Hoy en día la ciencia de redes se ha tomado la ciencia de datos. Los datos se están viendo cada vez más enredados, relacionados que como tablas. Entonces es un tema que hacia el futuro va a ser muy importante. Tuvimos más de 40 estudiantes en la primera versión de hace un año. Ahora tenemos más o menos 30. El curso pues ha sido muy exitoso y esperamos que disfruten del curso, que aprendan un poquito más de inglés, pero sobre todo que aprendan de esta nueva área del conocimiento, de crecimiento exponencial que se llama la ciencia de redes. I guess that was in Spanish, so the rest I'm going to talk in English. Thank you, Luis Fernando.
Thank you, Professor. Okay, yes, this is very important. This is a collaborative effort between the two universities. So we've been working on this like for over a year. So we held a class for the first time last year, a year ago, and this is the second time that we are going to offer this class. This is an interdisciplinary field, so anybody from any field could actually study this area. I don't know, maybe Professor, I would like maybe before actually going on this over the syllabus, maybe just to remember this, because I think this is important motivation about this class and why this is important not only for computer scientists, but also for mathematicians, statisticians, economists, or anybody from any field, even social sciences or human sciences. Professor. Can you please help me a little bit with this slide as a motivation? Professor, I think your mic is muted.
Excuse me, my mic was off. This is an interdisciplinary course, sociologist, anthropologist, economist. Networks are everywhere. We're going to see from the beginning that networks, graphs, redes are everywhere. So are studied, networks are studied by economists, mathematicians. They call in mathematics, they are called graphs. So this is going to be an interdisciplinary course. The course is based on I don't know if I could say it now, Luis Fernando. The course is going to base in projects. We are going to have two projects, and a small project and a big project. The main evaluation, I mean, of the course have to deal with projects. I don't know if I anticipate something that Luis Fernando were going to say.
Yeah, that's good. That's fine. Okay, so networks are everywhere, as the professor said. And maybe I should also emphasize what you just said, highlight what you just said, that this is we are going to have a practical approach in this class. So we're going to see some theory, but the most important thing is that you understand and you learn how to apply these concepts and methods to analyze networks, no matter what kind of networks you are dealing with. Yes, everywhere, there we have, as the professor says, social networks, economic networks, communication networks, citation networks, internet is a network, networks of neurons, knowledge graphs, regulatory networks, scene graphs. So in computer graphics, for example, 3D shapes, in biochemistry, molecules, artificial intelligence to represent knowledge, and also like in programming languages, called graphs. Okay, I think this would be for now good enough as a motivation, and then let's continue with the syllabus. Oh, by the way, at any time, please feel free to ask any question or make any comment. So, oh, sorry. I'm sorry. It was my mistake. I didn't share the screen. I should have. I'm sorry. My mistake. I wasn't reading you. Oh, I'm sorry. I'll go over that again just quickly. I'm sorry. It was my mistake. Okay, so these are the slides we were just talking about. You know that networks are everywhere. So you have social networks, economic networks, communication networks, citation networks, the internet, networks of neurons, and as I mentioned, artificial intelligence to represent knowledge, in biochemistry, in biology, regulatory networks, in computer graphics, scene graphs or 3D shapes, like in these examples, molecules in biochemistry, or if you're talking about computer programming, for example, programming languages, a way to maybe have represent some code, source code. Okay, yes, this is what I was talking about. I apologize for not having shared the screen, the slides. Okay, so now I will continue with the syllabus. Okay, so these are, this is going to be posted. We are going to tell you now afterwards about the communication channels that we're going to use. Email is a good way to communicate with us, but we're going to use Classroom, Google Classroom, and there you can post questions, and we're going to have some for this type of activities. Okay, so the goal of the class, network science. So in this case, what we're going to do is we're going to study networks, and we're going to analyze networks. So as a disclaimer and as also a warning, this is a neural networks class, because sometimes students get confused. And this isn't either like a graph theory class. This is about a new field, well, it's maybe not so new, that is called network science. So these are concepts and methods to analyze networks, or to study networks in general. But in this course, we're going to have a focus on how to analyze networks. And we are going to use, of course, the meaning of a network and give many examples about that along the class. So Professor Alfonso, Professor Fabio, and I are going to be in charge of the class. The goal of the class is to study the fundamentals of neuroscience. So we are going to study both commonly used and state-of-the-art methods for data analytics and their applications in problem solving. This is very important because this course has a practical approach. So we're going to see networks, we're going to study networks, we're going to analyze networks just in the context of solving a particular problem. So at the end of the class, you will be able to actively participate in data analysis projects that involve networks with the data science approach. Today, we are going to give a brief introduction, general overview about what data science is about. So the course learning objectives are, so at the end of the class, hang on, somebody's trying to join the session. So you are going to, at the end of the class, you will be able to understand and apply network models to complex problems, to apply the modeling and analysis tools of network science. So we're going to model them and also analyze networks. So we also will understand the advantages and disadvantages of modeling networks. And you will also be able to build, adapt, and analyze particular models of complex networks. So the contents, the several modules of the class are as follows. So first, we're going to have a brief introduction, a general overview about data sciences. We mentioned we're going to have a data science approach in this class to analyze the networks. So today, we are going to introduce the course structure and the evaluation, and we are going to give a general overview about data science. Then, we are going to give an introduction to network science, the basic concepts about graphs based on graph theory. So, Professor, maybe you could develop a little bit about this. What concepts are we going to study here in this module? Professor Alfonso.
Okay. In this first module of network science, we're gonna see examples of use of network science in many disciplines, and we're going to study basic concept of graph theory. A graph is equivalent to network. In mathematics, the word graph is used. In engineering and other disciplines, is network, so it's the same. And we're going to review basic concept of graph theory. What is a graph? What types of graphs exist? How can you find paths in a graph? And other aspects of graph that are basic for understanding graphs and networks.
Okay, yes, and I'm sure all of you guys have already crossed, in your life with some network, no matter what type of network you're dealing with. Even when you're studying, I'm almost positive that all of you guys have dealt with networks in your life in some sort. Since I saw, we have here engineers, we have biologists, we have I don't know. Actually, later on in the class today, we are going to learn a little bit about your background, and you're going to share that.
Luis Fernando.
Yes.
When you turn on the lights of your house, you are interacting with a network, the electric network.
Oh.
When you make a phone call, you're interacting with a network. When you are in the computer finding information in internet, you are using, I guess, the most important network of today. It's the internet. So really, they are everywhere.
Yes, yes, yes. Actually, you know what? Maybe we read you. So maybe you can mention as we speak on the chat some networks that you give some examples as we speak. Okay? So we read you. And you're welcome to share maybe some examples about networks that you've dealt with in your life or you study. So yeah, we're gonna go over some theory.
Angela Maria said innovation networks, very important networks, very important networks.
Good. Thank you, Angela. Stephanie, brain networks. Excellent. Yeah, I will continue here, and maybe you can help me read them, Professor. So yeah, it's important. One general idea that is very important that you keep in mind is that even in computer science or in math, we, if we have graphs of networks, what we usually do traditionally is we somehow represent the data, the graphs, the networks, as vectors. So that's why we will use all this theory about metric spaces in mathematics or in algebra. We deal with vector spaces. So we find somehow a vector representation, a linear representation of a graph or a network. So that's why you do, like for example, with calculus or with the linear algebra. And that's okay. And there are a lot of useful tools there. But the problem is that in general, you lose some essential important information about the network when you go to that linear representation or vector representation. Here, instead, in this class, we're going to try to preserve the essential information about the networks themselves to try to analyze them. So that's very important that we are going to do in this class. So we are going to deal with and study and manipulate the network without losing, let's say, that information about the network. So, for example, the nodes, we're going to talk about that, the connection between the nodes and all that. And so some of the main concepts at the beginning have to do with that. So some general and important information about the networks that you can study using network science, such as local and global measures of a network. Professor, so why do you
Yes,
are interested in local and
for
global?
example, when you have a network, a social network, for example, that is mentioned in the chat, social networks are very important. But not only social technological networks like Facebook and Instagram, but also social networks of the type of children in school. When you have children in school, they build relationships, and these relationships between childs in the school are very important for discovering problems that child may have. So social networks are two types of social networks: technological and real social networks. So a, a very important question when you have a network, for example, a social network, is what nodes of the networks are important, and why. What elements of what nodes could be considered important? There are many ways to answer that question, and we're going to see that. Uh, Another measure in a network is there are paths in the network. Paths in the network. So how big are the paths in the network? How much you can travel in the network? And another important is vulnerability. What happens if you have a network and some node of the network disappears or is not existent? So how how this disappearance of nodes affect the vulnerability of the network. Uh, how information is diffused in the network. What networks are easy for the information to be diffused by the network and what type of networks are not. There are a lot of analysis we can make of networks. And in this course, we are going to cover many of these aspects.
Professor, let me just maybe ask the students for some examples. I will ask them about, like, if you consider a particular type of network, so intuitively, what would you think would be like a node that would be important? For example, I know there are plenty of computer scientists here in the class. So if you think about a computer network, so which, and especially there you have, like, let's think about computers connected, like on the internet. We can think of in general as computers because even if they are like communication nodes, they still have computers inside. So let's think about computers in general. So what would you think that is an important computer in the network that maybe, as Professor said, like if it fails, for example, something bad can happen in the network? So I hear you, or I read you, guys. Can you think about, okay, Santiago, do you want to maybe explain again regarding the English? This is not an English class, but a network science class. So feel free just to communicate, no matter what. It's okay to make mistakes, and that's part of the exercise in this class. So Santiago, do you feel comfortable giving the example why a router would be an important computer or node in the network, Santiago?
Yes, well, I assume because it is like a central point, and from which different computers and other computers receive the internet or send information. So, because it's a central point, if that one fails, then other computers connected to it will fail as well. So there's like an open gate and a central point in that sense, I would assume.
Yes, 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 and and if it fails, then lack the communication will fail among some of the nodes that are there connected. Okay, good example. Thank you, Santiago. Uh, can anybody else give another example in a different context of an important node in a network from a different nature, not communication or computer related? There are Manuel Aponte. Go ahead, Manuel.
Thank you. I think that one example could be a communication tower, like some towers that have a lot of energy for different houses. And if one of those towers go down, then a lot of houses will be without energy or without internet. So I think that that could be a main node.
Excellent, Manuel. You're thinking about a power network, right? Like electric network, right, Manuel?
Exactly.
Okay, good, good. Yes, that's another good example. You see, and those are the things that, and maybe we can go over that one, Manuel. Think about maybe the central power centrals that maybe if, let's say, if it provides the energy for the whole city, and maybe we have another power central that provides just the power for a block, let's say, or a small neighborhood. Which one is more important, Manuel?
Teacher, could you repeat me the question, please?
Think about two maybe nodes, or in this case, power central. That one provides the energy for a whole city, and maybe another one that provides just power for a small neighborhood. So which one is more critical, more important among the two?
Okay.
As an
In
example
my
of the important.
Okay, in my perception, is more important the network that has energy for all the entire city because has more connection to different providers, to different clients. I mean, so I think that that's more important.
Exactly. It's excellent. That's what we are going to, right, Professor, to analyze. And it's related, as you mentioned, for example, to the connection, number of connections that one of these nodes has. And that's why it's more critical.
Yes, very good.
But,
Very good
Professor,
examples. Very good examples.
Very good example. And maybe we can use this. Can somebody something related to this? Can somebody think about another example? I'm going to go over what you mentioned regarding the, like for example, diffusing information in a network. And it's the same concept, right? In general, you know, like maybe a node that can diffuse information faster or to more nodes in the network. Can you think of an example? Who can give an example? I read you. I hear you. Did you understand the question where we are talking about? Is it clear?
I did not.
So we're thinking about the importance of a node. In this case, I'm thinking about, and as Professor mentioned, maybe thinking about a node that can be more important to diffuse information on a network.
Oh, yes, I see.
Okay, who's speaking? And let me see who's speaking.
It is me.
Ivan, right?
Precisely.
Oh, I think I know you, guy, right? I know you.
Yes, we have met before a couple of times.
Okay, Ivan. So good to see you again here. Ivan,
Thank
so
you.
give an example, please.
Well, I was thinking rather of organisms. Perhaps one may get a hold of a proper example considering an organism as per its organs. So it is possible to conceive of a certain organ within the organism that is particularly important to diffuse, say, a hormone or something of that sort to the rest of the organism. But I do not have a concrete example as such. I was just maturating the idea.
Okay, yeah, I think let me see. Just because I remember, I know him. I think we have biologists. Can you raise your hand here, biologist? Because I didn't think about you. Some example like you, I didn't have that in mind, but I think that could be a good example. I know that Wilber is a biologist, right? Can you? Santiago also. Santiago, right? Santiago, can you develop on I think his idea is important. It's a good example, right, Santiago? And I don't know
Well, I'm not a biologist. I was just making another example, but yeah, I think like in the brain, the thalamus is one of the structures where a lot of like cells connect and neurons connect. So it's like a hub where a lot of the information goes from one side to the other. So that would be like one of those nodes that you're describing, like a critical place.
Excellent, excellent. But you know what? I was thinking about maybe a more common example nowadays. I don't know. And let me just ask you. Oh, let me see. Somebody's also giving another example. Let me see who raised you. I saw somebody else. Let me see. Additional example could be something like yeah, Manuel Peña. Can you please? I was thinking about a social network. And maybe some of those nodes that can be very important to diffuse information.
Yeah,
Manuel.
I thought of Twitter, well, X, because in this case, this network, each user acts like a diffusion node, because in the end, for example, when you share or you retweet something, that is diffusion, and each user, that is each node, is helping to diffuse this information to other users and spread across the network.
Yes, Manuel, and can you please think of, and even you can give me names just as examples. So maybe, you know, I have like 3 followers maybe, or 4, but if I post some information or repost some information, that will have much effect. But could you think about somebody who maybe when they diffuse some information, when they post some information, that information actually diffuses because
Yeah.
a lot of followers. And how you call them, by the way?
Yeah, any influencer, yeah, an influencer or any streamer nowadays. For example, if they want to promote a product, I would call that an influencer, and an influencer would have an absolute reach to almost all users in the network.
Excellent. Good. Yeah. And Professor,
Okay,
the name
Luis
come
Fernando,
from... Yes, Professor, go ahead.
regarding what Manuel Alejandro had just said, and talking about diffusion networks, there are, I mean, positive diffusion networks like the Twitter, when there's influencers, but also there are negative diffusion networks. For example, you could have a network of a city or a town when you have a COVID, for example, or in a city you have COVID. If the nodes are other persons, for example, a driver of the Transmilenio is a very important node because uh, during the day he goes in contact with a lot of people, a lot of people. So the driver of the Transmilenio is like an influencer, but an influencer that could propagate an illness and COVID, for
Viral.
example. So diffusion networks can be seen as positive if you diffuse information, but as negative if a disease is being in the network. Okay.
Professor, even in social networks, with all this fake news, you have these bad influencers, that they diffuse negative information, fake news, and people believe them,
Of the fake
unfortunately.
news.
That's a good example. Thank you. Okay, let's move on. Thank you. And actually, the word influencer comes from here, from network science, right, Professor? The word the note that is an influencer comes from network science.
Yes. Comes from
Yes.
network science.
Exactly. Well, let's move on then. Okay, so we have some theory and about how to analyze this. And maybe, Professor, can you go a little bit about, I think the concept, and we are going to go later on that, the concept of community, because I think it's very important, this concept, right, Professor?
Oh, okay. There are a lot of important concepts in network science. The concept of community is very important. For example, when you see a network, a real network, it is very likely that the nodes of the network are unevenly distributed. There are clusters, okay? It's very common in real networks to have clusters. For example, in social networks, the nodes of the network tend to cluster with influencers, etc. It's very important to detect communities in networks because when you detect communities in networks, you know that there's something happening there. There's some patterns that are in the network. No? So this aspect of communities is very important. There's a lot of theory about that. There's a lot of algorithms. Uh, I mean, nowadays you can analyze networks of billions of nodes, not millions, billions of nodes. So there are important algorithms for detecting communities in the network, and this is an active area of research now. So we're going to talk a lot about communities in networks.
Yes, and but Professor, I think somebody gave an example here, like it was Manuel Aponte. He talked about a citation, maybe citations. So maybe when you talk about paper citations, there are people who collaborate and they somehow form a community, right, Manuel? And also
Right,
maybe
teacher.
social networks, we also have the same meaning. And also, if we go to biology, we can also have like some clusters there, some communities of cells, like in the examples that you guys were given. Okay, so, and then finally, I think, for some reason, I think I copied. I have to delete these two lines. I don't know why they are there. Copied. Um, sorry. Then in the last part of the class, we are going to have some some modules related to analyzing graphs or networks, but using machine learning techniques. So we need to introduce we need to give an introduction to machine learning and how do you perform machine learning with graphs or on graphs, and also at the end some methods to analyze graphs or networks using some deep learning techniques. So we're going to see some introduction to the learning and this concept that is very hot, by the way, these days, that is called graph neural networks, okay? So we're gonna do that with Professor Fabio Gonzalez. So it's using machine learning to analyze, or methods of machine learning and deep learning to analyze networks. And this is a very recent concept that it's very popular nowadays, very hot actually, still a lot of research on this, on graph neural networks, which are based on concepts of deep learning. By the way, okay, so this is the general outline of the contents of the class. And now we are going to talk, give some very important rules about how this class is going to be held. So I will ask, I don't know, maybe let me ask somebody, please, or somebody who volunteered just to get warm up, read some of these paragraphs about the student conduct code. So can you, somebody raise your hand and help me read the first paragraph? Okay, go ahead. It's Manuel. Go ahead.
Sorry, I was mute. Everybody in the class is expected to show courtesy, civility, and respect for one another. Students are expected to do their own work. Cheating, plagiarism, and any other form of academic dishonesty will not be tolerated. I mean, this will be a zero-tolerance policy. However, students are encouraged to discuss ideas and techniques broadly with other class members.
Stop there.
Okay.
So respect is the main word here. So we are going to respect each other. So we can maybe disagree sometimes, but if we are going to have like maybe some discussions, arguments about some of the concepts or whatever we are discussing in the class, so this is going to be in a respectful manner and an academic argumentation. So, and also, we expect you to have a very ethical behavior along the class. So no cheating, no plagiarism will be allowed, and that's going to be zero tolerance to this. Somebody else, thank you, Manuel. Can somebody else read the other two paragraphs? Go ahead, Ivan.
Okay. In the assignments to be developed in groups, not doing your fair share of work or allowing other students to receive credit for an assignment in which they did not work on is considered an act of academic dishonesty. It is permissible.
But hang on.
Okay.
So, stop there. Sorry. So we are going to have some assignments that you are going to work in groups, in teams. So everybody will have to do their share. Okay. We have different backgrounds, but still you have to put, your effort and contribute to the homework. So if you don't do it, or if you maybe allow us to give credit to one student who did not collaborate or participate in the assignment, that's going to be considered as an act of academic dishonesty. Is that clear? Okay, go on, please, Ivan.
Sure. It is permissible to use software and materials available from other sources as long as, one, you acknowledge explicitly which aspects of your assignment were taken from other sources and what those sources are. Two, the materials are freely and legally available.
Okay, so, and especially nowadays, there are many tools out there. You are allowed to use them as long as you state that in the assignment, okay? Also, you are encouraged to discuss ideas and techniques, with other class members. But when it comes to the assignment, and if it is individual, that you have to do it on your own, or that you do it in team, everybody has to contribute, or you can maybe discuss ideas with others, but at the end you have to present your own homework. I think Laura has a question. Laura?
Sorry, I left my hand. Sorry, I don't know.
Oh, by mistake. Okay. So, okay.
Yes, a mistake.
Laura, do you want to help me read this paragraph regarding some rules for the use of artificial intelligence in class?
Yes. 4. Rule for the use artificial intelligence. The student is allowed to use artificial intelligence tools such as ChatGPT to help gather information, generate ideas, or source code, but may not copy and paste information directly from the artificial intelligence tool and present in their own without sitting in. The student is responsible for information he or she submits based of an AI query and for ensuring that it does not contain missing information, unethical content, or violate intellectual property laws. You
Stop,
use the
stop, please
okay.
stop there. Sorry, stop there. So you are allowed to use it, but don't just take it the way it comes from the artificial intelligence tool and just copy and say that it was your homework. Because this, by the way, these artificial intelligence tools nowadays, they are not perfect and they may have errors and they may even violate intellectual property laws, or they have content that it can be considered unethical. So you can use it, but you need to edit it. You don't need to understand it. You need to read it. You need to change it and make sure that is the way it is requested in the assignments. Okay, go ahead, Laura.
Your use of artificial intelligence tools must be properly documented and cited to ensure academic integrity. You are expected to include a statement in your assignment describe which I tool you use to how you use it. For example, ChatGPT was used to draft approximately 50% of this document and to provide review assistance. I produced content was adapted for accuracy and style.
Is it clear? Thank you, Laura. Is it clear? So you are allowed to use it. You need to criticize the contents that they produce. You are expected to edit it or make sure that the information is right and is according to whatever we ask you in the assignments. And then you also need to state in the deliverable that you produce there, that the disclaimers where you say what artificial intelligence you use and how you use it to complete your homework. Is it clear for everyone? And actually, we encourage you to use artificial intelligence tools. Good. This is, sorry, somebody raised your hand. Who was it? Speak, please, because I cannot see. I'm looking at the syllabus, but I saw, it was Juan or somebody else?
It was me, sorry. But it was to say yes.
Okay, so you mean that it was clear. Okay, good. Yep. So, the class attendance, just to go faster maybe. Oh no, who was the one who spoke? Was it Ivan? No, who was it? The last one.
Me? Juan Sebastian?
Yes, Sebastian. Can you please just help me read this regarding the class attendance and absences?
Okay, class attendance and absences. This course assumes an interactive approach in its structure and its presentation, which requires engaged participation from all members of the class. Your presence is essential to the success of this course and accordingly to your individual success in it. Therefore, regular attendance is expected and considered mandatory.
Okay, go ahead. Then, so this is not only for you, but for us, and we need everybody to be in the class and be engaged and participate like we are doing. I think this is going wonderful today. So feel free to speak, feel free to ask, feel free to give examples. So this is going to be more fun for everyone, and you will take more advantage of the class, okay? Sebastian, go ahead, please, Sebastian.
Each student may have up to 3 absences in a class during the entire semester without direct penalization to their grade. Any unjustified absences of the student in the class could include penalties that may result from absences in class activities, handing in take-home assignments, or deliveries of the class project.
Okay, good. Thank you. So please, if for some reason, we are not, we can have problems. We may have some someday when maybe we cannot, we're sick or whatever. So please let us know that you are going to miss the class, or and if you have a justification, a reason to do it. So otherwise, you may get penalization for not being in the class or for not delivering the assignments. Okay. Communication channels. Professor, maybe you can help me with this, Professor, the communication channels, and maybe as we speak, as you, we can show the course webpage. Professor Alfonso, please.
The following channels will be used to facilitate the communication among the class participants. Also, all the participants will be asked to respect the purpose and rules of each one of these channels. Google Classroom. This platform will be used as the main learning management system, LMS, and will be the general channel to post and submit the assignments. In addition, it will be used as a communication tool for questions, for example. This will be a direct channel to give support and to receive feedback from the students. Students are encouraged to post questions and to help answer your classmates' in, in, inquiries via Google Classroom and to administer tests and workshops.
Okay. And Professor, maybe just let me, before we go to the course webpage, and we will browse it also. I'm not so sure the link is, this is updated. We'll correct it. We'll make sure that it's correct.
Okay.
Please, and we sent you a couple of files regarding some rules about the use of first, how to behave in these sessions, and also how to use, for example, the communication channels, especially if you guys are going to use some collaborative tools. So please respect the purpose and rules of each one of these channels. So, for example, in this open channel that we have here in this chat, and if at some point, maybe just as an example, two students start talking to each other and and the conversation there is just of their interest and not general interest, then just go to a private channel to continue your conversation, okay? Just as an example. Professor, and now let's go to the course web page. And let me just had it up. Shoot, I had it open. Wait. This is the website, the web page rather. Professor? Professor Alfonso? You're muted.
Sorry, I have the microphone off. Sorry. Okay, this web page presents all the information of the course. There's general information. If you go from left to right, first general information about the course, objectives, etc., teachers, and the emails of the teachers. The most important weekly schedule, week by week. Today is 7th of February. Week by week, there are the models of the course, but we are going to have slides in PowerPoint that you could download. The majority of the information we're going to give you with the slides, but there are also Jupyter notebooks. For example, we are going to use some collab notebooks for you to work and learn the network concepts. There are videos, there are reading materials. So there are plenty of information. Obviously, it's not to read all the information. It's too much, but you could choose if you want to see videos, if you want to read articles or books. There's a lot of information in this web page. So this is important. Here articles, online courses, important online courses. Look, there are a lot of courses. 5 years ago, there was no courses of network science. Today, there are a lot of complete courses in different universities in the world. So some courses let you see all the information of the course, videos of the teachers, etc. So this is an important fact. There are also videos about the different aspects of network science, internet links, data sets. Uh, these are in data sets. These are I mean, these are not data sets, they are network sets that have the data in the form of a graph, not in the form of a table. I don't know if it's clear. When you talk about data sets, you think of a table, okay? A data set, a table. This is, I put here data set, but in reality it's network sets because it's files that show the links. When you choose a file that are here and you open this in a program for viewing networks, you are going to see the network. We are going to see this. Computational tools. There's NetLogo, a very important language for representing networks. There, I guess the majority of you, I'm not sure, but use language Python. Python has a library called NetworkX, a very good library for analyzing networks. There's Gephi. The third one is Gephi, a very good tool for visualizing graphs. It's a spectacular tool for visualizing graphs. It has not much of analysis of a graph. It's Gephi's objective is to visualize and see communities, etc. But when you want to make deeper analysis, you have to go to NetworkX or iGraph. iGraph is a library of R language. You know that there are two important languages, Python and R. And NetworkX is a library of Python. iGraph is a library of R. And this is an overview of this web page. I guess I don't know, Luis Fernando. How could we send this link to the students
I
of
think
the web page?
I can post it now on the chat, but I think we need to send them tomorrow. Let's say an information regarding that Google Classroom, and because there are some links there. The material is not. Sorry, that was me. Let me just share it. Here on the chat, and then so the main website to post the main channel to post the material is the website, the web page rather. Okay, so this web page, and also let me go back to the syllabus. So we're going to use Google Classroom, and actually this was a decision because at the Universidad Nacional we use Moodle mainly, but we needed to work on an LMS that could be accessed by both of the students from the two universities, from the students of both universities rather. And then, so that's why we have to make the decision to go to Google Classroom. So we're going to add you. Let me just show you the outline of this Google Classroom. This is still the material, but for now, just let's focus on the general overview of the Google Classroom. Here we have still the material from last year. So we have information regarding the projects. So in this Google Classroom, what we're going to do, we're going to post and collect the assignments. So here we have the assignments, the projects. We are going to put the online section, the links to the online sessions. We are going to have some general information about the class as well. See? And some other resources and tools regarding each one of the modules. because each one of the modules has, here actually we have the assignments. So each one of the chapters of the modules will have the assignments about that particular module.
Luis Fernando, Santiago Rodriguez has a question.
Sure.
Are the recordings of the class gonna be posted in the web page or classroom?
Sorry, I didn't understand what is going to be posted. What was
the recordings of the class?
Oh,
I guess
that's gonna be private, so just for the class, not open on the website, but here in the Google Classroom. Okay, because we cannot leave it open like on the website. So it's,
it's very important, because if you miss a class for some reason, you could see the recording.
The recording is going to be here posted on Google Classroom. So that's going to be private to the students in the class. Okay, general information, resources, tools. Another question, right, Laura?
Hello, I have the question about the classroom, because I am to a Escuela Colombiana. I don't know. I enjoy in that classroom, or I don't know.
Oh no, we're going to invite you to the classroom. We haven't done that yet. Okay.
Okay. Thank you.
So you're gonna get the invitation to the. Here we have information about so we need to remove the students from last time, or you are going to be the new students, right?
Okay.
And also we need to hide here a couple of some information regarding the assignments of last, and we are going to be posting them as the term goes, as the class progresses. Okay, so that's what.
Okay.
But this is just, everybody will have access to it, Laura. So you are Laura. You are from the escuela.
Yes, I am from.
Yeah. So everybody. Yeah. No, don't worry. So everybody will have access. So all the students in the class will have access to the Google Classroom. So we're going to send you, I think tomorrow, an email about how to access this, and also the link again about the website. Okay.
Emmanuel has another question, Luis.
Okay, go ahead, Manuel. Manuel
Alejandro Aponte.
Yeah, go ahead, Manuel.
Okay, thank you. Will the segment be delivered to the classroom as file, or could they be GitHub links?
In general, there are going to be some reports. So usually you are going to give some written report, and there in the report you will give access to the GitHub. So if the assignment has to do with source code, okay, or implementations.
Okay, thank you.
Okay, so yeah, the last one is the GitHub. So we suggest you to use, because you're going to have, especially your 10 project, you're going to deliver some software. So we suggest you to use GitHub, and you're going to work in teams, by the way. So to collect and organize your information there in a file repository on GitHub, okay? And so the methodology. So we're going to have a project. So this is going to be very important in the class, and this is going to be developed in teams and groups. And we are trying to make interdisciplinary teams. And in this project, you will apply the concepts seen in the class. And each deliverable of the project will include a written component, Manuel, as you asked, and the rest of the students, of course, for the rest of the students, and also an oral presentation. So we are going to tell you next what are the deliverables of the project. So the concepts and method will be developed with the support of readings, and they are going to be posted there prior to the class. Since today was the first class, then of course we didn't give you this, but later on there's going to be the material posted there. So hopefully you will go over the material, some of the material in advance. We are going to present some of the concepts and methods, and some topics maybe will be developed by the support of presentation by you guys. Some individual and collaborative written exercises will be developed to reinforce some of the concepts. And some practical practical exercises will be developed to reinforce and apply the concepts studied in class. So now grading, which is also very important for you guys. So we're going to have some assignments, some homeworks. So we're going to have some labs, the Google Colabs. So we're going to have, as Professor anticipated, we're going to have, this is very important, a small project. We call it last time mini project, small project, because then you get a sense, a feeling of what is, how do you proceed when you analyze network data. And then we are going to have the main project of the class. We have it's a very significant percentage of the class, and which we delivered in the same general three components, or three presentations, right? Three stages. So at the beginning, you will have to present a proposal, and we'll give you all the information about how to present the proposal. Then we have a project milestone, a prototype you will need to develop here in the second deliverable. You will have to perform already some analysis, and you have to present a prototype of that implements the analysis, the first analysis, and at the end you present a final report of the whole project when you perform the whole analysis of the networks and address some, or rather solve some of the questions that you posted at the beginning with the proposal, okay? And this has to be at the end, as we mentioned, you're going to deliver an oral presentation. So in each one of the presentations here, you will have a written document and an oral presentation. Okay, so you have to present in class what you have accomplished so far on your project. We will have some forum there, and so we will get extra points. So we encourage you to participate in this forum, posting questions and answering the questions of the forum, or all the questions that the students, your classmates, post on Classroom. Let me see.
Oscar Alvarez, raise your hand, Luis. Oscar Alvarez, raise.
Oscar, go ahead.
Teacher, in the project one, what is this network X code?
Oh, yeah, Professor. Yeah. Professor, you can develop on that because you know the answer. And you mentioned just now the use of the library on Python. Professor, please.
Could you repeat me the question, please?
He's asking what this. Yeah, maybe I skipped this. Sorry. So what is this network code? Network X code
okay.
About? Sorry, I skipped that. Sorry, Oscar, and everybody for not having explained it.
Okay, network X is a library of Python where you could develop your projects. It's a very powerful library. It's highly recommended. In the last version of the course, the majority of projects were developed in NetworkX. So that's why we put NetworkX code. But it is possible. It is possible that you are familiar with other libraries of analysis of networks. So we recommend NetworkX, but it is possible that you could present your project and present your code using another library, for example, iGraph or NetLogo or this. We put there NetworkX because it's the standard, I guess, and have a lot of documentation and when you see articles in the internet, the majority of studies are made using NetworkX. Okay.
Sebastian, I'm sorry, but you are not, and that's part of the goals of the class, that you need to not only learn about network science, but also how to work in teams. So you cannot work alone. You have to work in teams, and that's part of what we expect and what we're working on when we in our educational process with the students. Okay, so you need to learn, not you but everybody need to work as part of a team. When you go to a company when you get a job, you need to be able to interact with other people and you need to work with other people. So you need to practice this in the university, in our university and part of classes. Okay, Sebastian? So you need to work in teams. Sorry about that. So the answer is you cannot do your project on your own, by yourself. Okay? And that's part of the, and especially in our students, in our Universidad Nacional, let's say the companies complain that our students, our professionals don't know how to work as part of teams, many of them. So we are working hard to try to solve that, okay, Sebastian? And that's a good message for everyone. Okay. Let me see. I think we're almost done with the.
Okay, Luis, let me answer to Hernan Santiago Angarita. He says, anyone interested in music topics? I'm a musician. Yes, I guess 1 year ago there was a project about music. There are a lot of networks about music, about jazz, networks of musicians of jazz. And this is a topic. This is a topic, important topic. So if you, Erna Santiago, are planning to do a project in music, there are a lot of networks you could use, and it would be very, very. I think it is very important, and I think you know it, that your project is something that you like. There are networks for nearly every topic, so it is wise to choose a project of a topic that is very fun to you. Okay, that is important.
Okay, thank you, Hernan. Hernan, are you there, Hernan? I think he's also asking if somebody in the class, right, Hernan, is interested in music, right? Hernan, are you there? Hernan, can you speak? Hernan, can you speak? Do you have your mic on available? Hernan. Oh, no, he did not answer. Let me just ask somebody because this. Oh, you can speak today. Okay. Oh, Sebastian, can you please tell me? Okay, so you also say in discrete event systems. Sebastian, are you like an electrical engineer or something like that? Sebastian Hernando Campino? Sebastian Campino?
I am mechatronic engineer.
Okay. So, Sebastian, right?
Yes.
Can you have me read this out loud, please?
To meet the objectives of the course, the credit for partial delivers on the project development will only be taken into account when the project final report is delivered. To make it clear, if the final delivery of the project does not occur, the total grade assigned to this course activity will be 0.
Is it clear, Sebastian and everyone?
Oh, yes.
Okay, so you need
Yes,
to
it
go.
is.
To commit until the end, because and I started doing this, and I suggest the professor to do this because some students just quit in the middle of the class, or they say, okay, with all the grades that I have accumulated so far, I can pass the class, then I will obtain a passing grade, then I want to be in the final deliverable of the project. So if you don't do it, sorry, you won't get any credit for the whole project. Is that clear for everyone? So you need to commit with your team until the end. Okay? Otherwise, you won't get any credit for this activity in the class. Okay? And here we have a basic list of references. There are many more there on the website. Okay? And Professor, I think it's good that we also get to know a little bit about them, right, Professor? So this is, first of all, Professor, I don't know if you want to say something else before I I share this file and maybe get some information from them. I don't know if the time to go, we have like 30 people, but I think we can do that, right? Like ask them to introduce themselves fast, quickly, so we know who they are. Right, Professor?
Okay, perfect.
Okay, so maybe, and I will start marking them here, just to make sure that, Johan, are you there? Just tell us who you are, and I will ask you, I will share this file with you guys, and I will ask you to please give us a little bit more information about your background, especially graduate students. You know, graduate students, what is their undergraduate program, right?
Luis Fernando.
Yes.
When the students are presenting, I would like to know why are you in this course? What brought you to matriculate in this course?
Okay.
Because it's important to know that, so they can the name where they studied and why they are here.
Okay, good, very good. And we will ask you as you speak also to please provide some information that is going to be useful for us to make up the teams afterward later. So the background, and your interests and your expectation about the class. So let's start with, introduce yourselves, tell us your name, your background, and why you are in this class, okay?
Luis Fernando, 1 second, one more second.
Yes.
And they could open the camera for
oh yes, please.
If they can for a little bit.
Yes, please. Of course, respecting your privacy. Let me see. For now, I guess anyone with a link can be, for now, unedited. So you can modify this. Let's hope nobody else gets to this file. So I will share this file, and you can see. Yes, respecting your privacy, please, as you speak, if you feel comfortable, of course, you are not like obligated. So if you don't feel like maybe we are violating your intimacy, your privacy, then please let us know, and you don't need. But we would love that you guys turn on your camera as you speak, so we get to know a little bit about you, and also put a name, a face to your name. So Johan, go ahead first. You first. Johan, you there? Johan? Is Johan on? He's not on, right? So let's move on to Lady Aldana.
Yes, good afternoon.
Yes.
Okay, my name is Lady Aldana. As a background, I have studied systems engineering at the Distrital University. In addition, I think that this course will help me a lot in order to structure better the purpose of thesis that I am making. It's related with cybersecurity and machine learning.
Good, great. Let's move on to, and also please provide that information here on the slides on this table. So Oscar Alvarez.
Hello. Okay. Graduate the last year engineering systems. This year I'm studying mastery engineering systems investigation, and I had hidden a topic thesis, and this class I explore to choose the two shows topic. Yes.
The topic of your research, maybe your thesis, yes, or something like that, or your project. Oscar, is that why you doesn't help you with that?
No. Can you repeat me, please?
No, I was trying to help you, maybe, because say it again, please. And,
okay.
Breathe and don't Don't worry, just say it the way you feel. Okay.
Okay, okay. And the expectation is view uh, deep learning is a topic about in the syllabus. I see.
Okay, it's to learn the topic. Okay, thank you. Hernan, so I think you said you cannot speak. If we understood you well, maybe we can read you. Okay, if you said you cannot speak, Hernan and Garita, you cannot speak today. So please try to make it sure that you can have a way to communicate in a spoken way and also maybe show your camera at some point. Manuel Aponti.
Hello.
Yes, go ahead.
Okay, thank you. Hello, everybody. I am Manuel Alejandro Ponte. I am multimedia engineer. I have like 1 year of experience in machine learning, and I would like work in the future in multimedia information retrieval. And my interest topics are natural language processing, computer vision, and 3D applications.
And do you think this class is going to help you with that, Manuel? Your plan?
Yeah, I think that is very important because in multimedia information retrieval, I think that is important seed information, not always like tabular, but also like a graph. And I think that could be very rewarding for me in the future if I understand more these
Yes.
topics.
Excellent. Thank you, Manuel. Angela, are you there? Angela? Angela is not there, I guess. Sergio?
He's writing in the chat.
Oh, she's okay.
She's writing in the chat.
Okay. Sergio?
Okay, hello, I am Sergio Arguello. I'm electronic engineer of the University Distrital Francisco José de Caldas. I know about this course because I see the presentation of 2 weeks ago, maybe 2 weeks. I think I am very interested learn how to apply this the acknowledgement of this class for bioengineering.
Okay, great. Sebastian Campino.
Oh, yes. Oh, hi. My name is Sebastián Campino. My major is mechatronic engineering. I was admitted to automation master. Uh, so my main topic of interest is discrete events for production lines in manufacturing systems. So I hope to learn more about networks. That's it, I guess.
Thank you, Sebastian. Ivan Cruz.
Hello, good night or afternoon, I suppose. I am an undergraduate student of systems engineering, and I am partaking in this course as it will allow me to finally graduate. What may I say? I was motivated in particular to attend to this course because it is being imparted in English and because I have long been motivated by the concept of what a network is.
Okay, thank you, Ivan. Johan Vilus. Johan? Johan is not there. Johan, are you there? Johan? I think he's not there. Farid.
Good night for everyone. My name is Farid Estepa. I studied mechatronic engineering in the National University. And I am interested in this course because I work in the industry. So I want to know more about the networks in the in the field of the sensors and the controllers, because nowadays the industry 4.0 is gaining relevance. So the IoT devices are getting more importance.
Great. Thank you, Farid.
Can you
Laura Molina. Laura, are you there? Laura? She's not there? I guess not. Stephanie? Stephanie?
Hello.
Hey.
Hello. My name is Stephanie Gonzalez. I am industrial engineer of the Catholic University of Colombia. I am in the Master of Industrial Engineering, DPING. I am in this course because my most of my laboral experience is in business intelligence, and I think this course may be cool. I hope to take it to another level.
Good. Thank you, Stephanie. Polo?
Hi, how are you?
Hello.
I hope that everyone here in this room is fine. My name is Paulo Andres. I am electronic engineer. I am a student of the doctoral engineering of the systems. Well, I want talk about of me for a short topics. I finished the last semester the master of the industrial automation in the University Nacional of Colombia. My first reason that I am very interested in this course is because I wanted to apply this knowledge in this moment in my job, because I think that I can support several things in these terms, and I think that I am very passionate for these topics.
Okay.
So I am with all the disposition for learn here. Thank you.
Great. Thank you, Polo. Wilber.
Hello, everybody. Good night. I studied biology at the National University. I interested in the course because I want to learn about the concept or topic about the deep learning. In the future I can apply this concept in the field genetic analysis, for example, the DNA sequence and proteins analysis.
Good, great. Manuel Peña.
Hello, everybody. Good evening. I'm a system engineering. I did my undergrad on the Politécnico Gran Colombiano, and I'm on my last semester for the Masters on System Engineering here in the National University. I have been mainly focused and enrolled in development most of my career, so I have been working on development over 10 years now. And my interest is mainly video games, so I try to see how to integrate any knowledge that I can into it. So that is why my main interest here could be said that is mainly academic. I just want to learn this. And I also think that we need to be in touch with the latest technologies, and understanding how to perform this data analytics via network science is a great knowledge for our toolbox. So we can be used, it can be used in our works and stuff. So good evening.
Thank you, Manuel. Henry, are you there?
Yes, I'm here. Do you hear me?
Yes, go ahead.
Okay.
Henry.
I'm a chemical engineer and industrial engineering from Universidad de los Andes. I have a master's degree from Universidad Nacional de Colombia in industrial engineering. I'm currently in my second semester of my PhD in Industrial Organizaciones from UNAL. And I want to, well, what motivates me to study or take this course is I want to, for the past decade, I have worked in supply chain management and logistics, and those are mostly networks, providers, suppliers, clients, everything. So it's the reason I took this course.
Great.
Le abrió el micrófono, creo que a Farid.
Somebody open the mic. Can you please mute the code closer, or we have to mute you? Thank you, Henry. Juan.
Hi, can you hear me?
Yes, go ahead.
Hi, nice to meet you. I'm Juan David Ramos. I'm an electronics engineer, but I have been working as a developer for 10 years. I'm currently studying my master in systems engineering, and my interest in this course is it's related to the thesis, because I'm developing a artificial intelligence model to improve the quality in a microservices system. So I think that's very related, and I think that I see a lot of networks there.
Thank you. Juan. Santiago Rodriguez.
Hi, my name is Santiago Rodriguez. I am currently an undergraduate in System and Computer Engineering here in the Nacional University. I decided to take this course because when I saw graphs and graph theory in class, I thought it was really interesting, and I know this is related to that, so I wanted to expand on that. And the topics I am interested in are biology and medicine and databases and data analysis. And that's it.
Good. Thank you. Paula Rodriguez.
Good evening. My name is Paula. I am computer scientist and mathematician, and I am currently pursuing a master's degree in applied mathematics. I am interested in graph theory, in the properties of graph, mostly theoretical, but I feel that it's important to apply that theory in the real world.
Great. Thank you, Paula. Duban.
Hello, good night. As you said, my name is Duban Casero. I am mechatronic engineer from Universidad Nacional. And currently I am a student of industrial automation. And my interest of this course is about first learn about networks and how can we apply this to loop of control.
Okay, thank you. Sergio Vargas. Is that there? Sergio. Jorge.
Hello.
Go ahead.
So, hello everybody. I am Jorge Zavala. I am biologist. Right now I am in the bioinformatics master, and I decided to take this class because I have an approach in another course, and I'm looking forward to learning.
Thank you, Jorge. Laura Moreno.
Hello.
Hello, Laura.
My name is Laura Moreno at the Colombian School of the Engineering Julio Garavito. And the reason I take this class is because, like industrial engineering, the networks or the analyzing data, giving me the tools to improve any process at the company. Because when analyzing or visualizing complete data sets, I make strategies to do in any company. Thank you.
Thank you, Laura. Then we have another Laura. Laura Chacon. Laura, are you there? The other Laura? She's not there. Pedro.
Hey, can you hear me? Wait,
Yes.
turn on my camera.
It's Pedro.
Okay, I don't know if it, okay, it didn't turn off on, but okay. Well, I'm a mechanical engineer from the Escuela Colombiana de Ingeniería. Right now I'm cursing my second year of the master, and I pretty much like course this class because I really want to understand how networks are like communicating between them, how those work. I don't have many experience in programming or in network as you can already know, and I think it's very important for my thesis and my future projects I want to make to understand how network science works, data analytics and stuff, because I think mechanical design and industrial design, because my master's in industrial innovation, are very important, and I really want to like apply all the things I can learn here and take different courses in the future, and that was pretty much it.
Okay, thank you, Pedro.
Thank you.
Valentina.
Yes,
Valentina. Go ahead, Valentina.
okay, I am Valentina Ruiz. I am an industrial engineering. Now, currently, I'm an student of Escuela Colombiana de Ingeniería, and I'm here because I have heard a lot of times like the term of network science using data analytics, but in our program there is not like any subject of that, so I decided to benefit with this option, and because I know that it is now important and in the future will be more important to know about that.
Thank you, Valentina. I'm not so sure about these other students, if they are available because they are not registered. They emailed me though, and I just included them. Carolina, Luque, are you there? Did you join the session? I guess not. Natalia Cortez, did you join the session? I guess not. Angela, yes, you are, right, Angela Cardenas?
Yes.
Go ahead, Angela.
So, good night. I am last semester student of system engineer at the National University of Colombia. I decided to enroll in this class because the topic caught my attention, and I wanted to improve my understanding of networks. Besides, my expectation of this course are I wish to strengthen my understanding of networks, become familiar with data analytic tools, and grasp how to enhance software development by leveraging networks. Additionally, I hope to acquire knowledge that I can be applied in my future professional life.
Great, thank you. I guess, one, Sebastian, right? You are connected, right, Juan?
Yes, I'm here.
Go ahead, Juan.
Okay. Let me turn my camera on. Okay. Yeah, so my name is Juan Sebastián Vargas. I'm an undergraduate student of Ingeniería de Sistemas. I'm finalizing my studies here, and I got interested in this subject because last semester I made an internship in data engineering, and I worked with HR data basically and people data. So, fun fact, I got interested into the data science environment because of Professor Fabio with its introduction to intelligent systems class. So I started there, and then I got the internship, and now I work as a data engineer. And I want to take my professional career to the next level, I want to learn more about data science and AI in general, and this seems to be fairly interesting. So, yeah, that's why I am interested in this. I don't know why it didn't let me register this course. I hope it will let me. But I'm interested in the Maestría en Ingeniería de Sistemas, which this is a subject of this. Eventually, I would like to see more information about that. But in the meantime, I'm taking this as a electiva, eligible course. So yeah.
Thank you for your interest. I think you. I guess yeah. I did wanted to stop, Professor, because we usually by around 7:30 we Laura is there. Sorry, Laura and Johan. Yeah, because we usually have a break in the middle of the class, but let's allow them to introduce themselves, Laura and then Johan, and then we take a break. Okay, Laura, are you there?
Yes, can you hear me?
Yes, we can.
The last time you didn't hear me. Okay, Laura, I'm an environmental engineer, and I am data science master's student in the Escuela Colombiana de Ingeniería. I take this course because nowadays we have a lot of information, and it's important to understand it and use it for decision making. But additional, if we can find a relationship between this information, it would be a tool that would enhance the information process.
Okay, thank you, Laura. And now Johan.
Can you hear me, teacher?
Yes, very well. Go ahead.
Sorry, I have some problems with the microphone, but I'm with the cell phone to talk. Well, I'm an assistant engineering. I made my undergrad work about digital pathology, working with some models like based in machine learning and deep learning. So why I'm here? The reason is that I want to deep into this kind of models, and I see that it's very important to understand all kind of data. So in this case is we're gonna work with graphs. So that's my motivation in this case. I want to explore all the kind of data to improve my knowledge in machine learning and deep learning.
Oh, sorry, I was speaking without the mic on. So we're going to have a 10-minute break, okay? And please provide the information that we requested there on that file. And we'll meet in 10 minutes. So we'll have so you can stretch, and we'll meet in 10 minutes. 10 minutes, okay?
Okay.
All right. So everybody back. So we continue with the class. On my camera. So we are starting today with an overview about what data science is about. So,
Teacher, I have a question.
Go ahead.
Do you have a investigation group?
Yes, we do have a research group. Our research group is called the Intelligent Systems Laboratory. So it's called in Spanish LISI, Laboratory.
Oh, easy. Okay.
Intelligence.
Okay.
Okay, so if you're interested, you feel free to contact me in private. And so we have a weekly seminar with the students. And so you're welcome to join it and just see what it is about. And we can also have maybe a private meeting to talk about what we do in our research group, okay?
Okay.
Okay. And thank you for the question. Okay, so I'm going to give you a general overview about data science. So I guess all of you guys are now conscious of the, or aware rather, of the value of data today. So data has a lot of value today, and they even call it like the new oil of the digital economy. And basic concept that is very important. We computer scientists, we understand the difference between data, information, knowledge, and wisdom. But in general, common people, like regular people that maybe don't have a background in computer science, for them it's like data is the same as information and then knowledge. But why these concepts are very important? Because when data science is about getting knowledge and about getting wisdom from data. As a particular example, this is one figure that I once found, and I think it's very important to illustrate what is the difference, the intuitive difference between data, information, knowledge, and wisdom. So data is just symbols, numbers, but without a meaning, and we call them raw data or data. So, for example, in that case, red or a number, some symbols there, but without a meaning. Once you give them those symbols, those numbers, a meaning, then we talk about information. And this is a very nice example, because in this case, for example, red and one collection of numbers that may mean in particular context, and information is very important because it's about the context that the data takes some meaning. In this case, those numbers that are below will mean that the south-facing traffic light on one particular corner of Pete and George, in this example, streets, has turned red. That could be the meaning. So those numbers, red, and that particular, I don't know, it looks like an IP address, right? So a particular traffic light is turned red in a particular intersection of those two streets. And when you talk about knowledge, you get more information about the context. So in this particular context, it could be for example, a particular car that I'm driving that is giving me some signal. So the traffic light I am driving towards has turned red. So it gives me more information about the context, and that's what knowledge is about. And on top of the pyramid, we have wisdom. And that's one of the main goals in the future about data science, is to try to get very, very important information from a particular context. So in this case, wisdom is when you apply the particular information or the knowledge. In this case, if the traffic light I am driving towards has turned red, then a decision I need to make is what? I better stop the car. This is a very simple example. I don't think stopping the car is just something like about wisdom, but because you could think of this and a simple decision. But that illustrates like the complexity of the decisions, of the value of the information, rather. And data science has been triggered by the growth, the very fast growth of data, and this is mainly because of the internet and also the access, the availability of some technologies. So this has been growing, well, we say exponentially, but the mathematicians may say that maybe it's not exponentially, but polynomial rather. But intuitively, people talk about exponential, meaning that it grows very fast. And a lot of that data is not structured as we usually have been used to, but rather unstructured. And maybe a computer scientist can help me. What is the main difference between structured data and unstructured data? In the introduction, some of you guys said that you even are data scientists already. Somebody, please, quickly. Difference between structured data and unstructured data. Hello? Did everybody leave? Maybe you can, Stephanie.
I don't understand the question. Structured data and structured data.
Yeah, what is the difference between structured data and unstructured data in computer science? Manuel, can maybe give the information, Manuel Aponte? Please.
Okay, thank you. Okay, for me, structured data is data that is tabular, that could be found in data sets, that could be found in tables, but unstructured data is data that is not saved in tabular format, like images, videos, like, for example, a JSON information or a dictionary. I think that those could be some examples.
Yes, yeah, that's a very intuitive way to put it. Structured usually refer to data from people, persons, places, sensors, figures. Usually you can post them or organize them as a table. Numbers, for example, places, some are addresses. A sensor gives you information about, for example, the temperature, or these days that we have these problems like the quality of the air with a number, and usually you organize them as tables, addresses, barcodes, statistics. Numbers, usually. While structured does, somebody has, Stephanie, can you please close your mic? Unstructured data instead are data like very common today as social network data, clickstream data, some device-generated data, for example, from historical records, logs, images, videos, sounds, some internal documents of the company. Even when you go, for example, in the context of medicine or in other contexts, you take notes and you put them not in a tabular way, as Manuel said, but in a different manner. Or biological data, for example, most of biological data are not structured, or we call them unstructured. And the features of the data nowadays, and it's what they used to call like the big data, is that they are big, in volume. So, and they are characterized by these. So volume, velocity, variety, veracity, and value. So raw data take a lot of space. So it means that when you collect it, it takes a lot of room on the computer, on the memories, or the storage devices. The velocity, because they change in time quickly and you collect it in a fast manner. There is a very diverse, there are many types of data, so they are very diverse, so they have variety. And one of the main problems is the veracity of the data, the quality. So the main question is, can it be trusted? And another important thing that relates to data science is that the value of the data. And as I mentioned about this, like one of the main assets of digital economy today. So it's some information that is very useful and very valuable for decision making in the companies. And some of you guys mentioned that during your introduction to the class. So I'm just gonna go fast on this. We will post this, but since we don't have much time today, I'm gonna just focus on some of the slides. This one. So one of the main objectives of data science has to do with getting from raw data knowledge that is valuable in the particular context. For example, about a patient, about the company, how are my sales going in the company, or how should I invest, for example. So it's going from data, passing through information to obtain knowledge that is important in the particular context for decision making. So it's transforming the plot or raw data into scientific or in general into knowledge. Some of the data scientists, can you maybe help me explain these two arrows, why this one goes in this direction and the other one on the other side goes in the opposite direction? Can anybody give me an intuition about that? Computer scientists, someone, or any of the data scientists here? Help me explain the directions, these two arrows. Anybody? So this was Sergio. Sergio.
Okay, I'm not data scientist, but maybe I try to learn this. I think that in the topic of value, this is a process when, and then in one step I grow in the value of the data. Maybe it's I advance to the data, transfer information, transfer knowledge, but then the value is it's major. But in the other case, the volume, I I don't know how to say it. The quantity of data reduce in volume, because I filter this data for transforming an information and transform on knowledge.
Okay, that's important, but I'm not so happy about the explanation about this value, but I think Manuel can complement your answer. Manuel, I think.
Yeah, what I think is that it is like going from general to a specific, or from a specific to general. So when we have a lot of volume for the data, we can found, for example, generalities like markers or tendencies or trends. But when we want to get to the specific, to get to the knowledge, we want to reduce this to specific things. So we want to start by looking the specific value of the specific fields or the specific parameters that we want. So we start to lower the volume to get some knowledge from the specifics.
Okay, Sebastian, can you complement, because I think this is very important. This is the core of the data science. This is in the core. Sebastian?
Yes. I see it like when you take the data you have on your sources and you start to process it, you start to remove empty values, you start to cast data types, you start to connect or join tables. There's where you go from data to information, and then if you're building perhaps insights, or if you're taking decisions, you can transform it into knowledge. That's why volume reduces, because of you're removing values sometimes, and that's why value increases, because it's where you can take decisions. Is the way I see it?
Yes, actually, that's the best. The last part of your answer is what is important. You get insights from the data. Like in this case, if you look at these numbers, it doesn't mean anything. It doesn't give you much value to make decisions. However, if you move in this direction, I better stop the car, otherwise I'll get on a wreck, and I may die, So this is valuable information for me in this case, in this example. Here, these are just numbers. But as you move along, move up here in the pyramid, you will get useful information. In this case, of course, my life is in risk. But if we are thinking about like decisions for a company or whatever the context is, for example, if it is a patient, the patient may die. If you don't get this knowledge will help you save the patient, or this knowledge will help you save the company. Make decisions about how to increase your sales or whatever. So this is why the value for making decisions is more important, because you get insights from the data. Okay, and this all has been triggered by the data deluge. And I think later I will make the difference between, distinguish the difference between data science and big data, but in general, you think about data, big volumes of data that will provide information about the data. And this is, I think this is very important about how the model has changed and has given, has generated this new field that is called data science. So in the old model, few companies were generating data and the rest were consuming. So we were consuming data. You know, regular people, we were consuming data. But the model today is all of us are generating data. And again, all of us are consuming data. This is important because not only some particular people or companies are producing the data, but everybody, the companies, the organizations, the hospitals, the government, we as citizens are generating data, and all of us at the same time are consuming the data that we are generating. And data science is in the middle of these disruptive technologies today, and in which two of the main technologies there are the cloud and big data. The big data in general refers to technologies to handle all these big amounts of data. And just because I think this is important, and they are somehow intertwined, and they are related. We have data science, but we have also some emerging technologies, and this what's been called the fourth industrial revolution: artificial intelligence, blockchain and distributed ledgers, citizen engagement analytics, cloud and high performance technologies, nanotechnology, new manufacturing, robotic aerospace, smart platforms, and virtual worlds. They are all intertwined, and the data science is somehow in the middle of all of them. Let me just go, I will go fast on some of this. Very important. So one of the main fields, let's say, or one of the main interests in data science is to perform data analysis. By the way, data analysis has been there for a long time, and especially is what statistics has been devoted to, you know. And part of tools, concepts, areas that have to do with data analysis are like quality control, experiment design, business intelligence, and machine learning is in the middle of all that, and exploratory data analysis that is basically statistics. But I think this is one of the most important charts in today's talk. So one of the main goals in data science is to get knowledge from data, and for that you will need to perform some analytics, some analytical processes. So there are several ways to perform this analysis, and usually, you know, based on in classical traditional statistics, you perform what they call retrospective understanding. So when you go over the data and you look at and get some descriptions of the data, what you get is what happened. I remember, yeah, you all were there. We all were there, you know, when the lockdown happened because of the pandemic. You know, remember every day they used to post like in Colombia, and I'm sure in all the countries, they produced this chart where they announced how many people got infected the day before or the week before, and how many people died, right? Remember? Well, we would like to forget about that because that was awful. But when they perform this analysis, they just show some statistics. That makes sense. Sorry. Okay. Professor, if you help me, if you see that maybe we need to address some of the comments, please let me know, because since I'm looking at the presentation, I cannot follow the chat. Let me see.
Okay.
Let me see what Hernan said. Oh, he was talking about his introduction. But Ivan, I think, yes, Ivan, can you please develop your statement there on the chat about data science or data analysis? Ivan?
Oh, well, of course.
I just meant to say that it is extremely difficult for us to make sense of huge volumes of information or data, to use the proper term, so that it comes natural that as we gain knowledge, volume should go down.
Okay, got you. Thank you. Thank you, Edward. So I'll put that example about like the COVID-19, data that they posted every day, like our Ministry of Health posted that information. So it just, collected the data and just summarized it about what happened the last day or last week or last month. So those analyses just tell you what happened from the data. For example, in that case, they say, last week we had so many people infected, so many people died, unfortunately, and so. So those type of analysis, which are very popular in statistics, they just tell you what happened. So you take the data and they tell you what happened. For example, if we're talking about a company and you take all the sales information, then you say, we sold how much millions of pesos or dollars last month. And the product that we most sold, if it is, for example, electronics, we sold the iPhone, whatever number they have now, 13, 14, whatever it is. But they just tell you what happened in the past. So they describe, they tell you what happened in the past. But, and that's what traditionally has been done traditionally with statistics. But you want to get there further, beyond. So you need to inquire and ask, why did this happen? First of all, why? Try to get some answers to the question, why did that happen? And if you advance some more, then we'll say you, okay, so I'm trying to anticipate and try to figure out what will happen. For example, how many more people will die in the case of, or will get infected in the case of the COVID-19, or how much I'm going to sell next month, next year in the company, or so, that kind of things. So you are more interested in also looking at the future, what will happen, and even more, how can I make something happen? I want to increase my sales in such numbers of millions of dollars, for example. So how can I make that happen? That's of a lot of interest for the company. Or in the case, going back to the COVID-19 pandemic, how can I prevent people from dying? How can I prevent people from getting infected? Okay, so we go from retrospective understanding to prescriptive understanding, prescriptive analytics, trying to see what's going to happen in the future. And that's what's very important in data science, trying to answer from data some questions that are important in the particular context of my company or the patient or whatever it is. Okay. One of the ways to approach this is this analytics is what has been called knowledge data discovery, which usually, you have start from a data set, you select some of the data, you perform some pre-processing, you transform the data, you perform some data mining processes, and at the end you get some insights, some results, some conclusions. So you evaluate and interpret the results about to try to answer some questions that you posted from the beginning. So data science is concerned with collection, preparation, analysis, visualization, management, and preservation of large collections of information. And it is not only analyzing data, and I guess I like an equation. And by the way, this paper is very posted, and will need to read it. It's one of the best papers I've found. I try to look for some better survey papers about data science, but it's the best I've found so far. And I guess this equation summarizes, I love it, that the way they posted in that paper. So data science is not computer science, is not just computer science. See? Yeah. Okay, so I have here some mathematicians. Can you raise your hand, mathematicians? I guess there is one only. Paula? Paula. Paula is there? Isn't she?
Hi, teacher.
So you know you're very familiar with the questions, but this is a different type of equations. So can you help me read the equation? So what is data science about? It's a combination of what? A sum of what?
According to discipline-based data science formula is given as follows. Data science is equal to statistics plus informatics.
Wait. You say statistics?
Plus informatics.
No. What's the first one? I think correct me because I think it's important. What area is that? What discipline? What discipline? The first one.
Statistics.
Statistics.
Perdón.
Statistics, right?
Sí.
Statistics plus
informatics.
Informatics.
Plus computing.
Plus computing.
Plus communication.
Communication.
Plus sociology.
Sociology.
Plus management data.
Okay.
Management plus data.
Plus
environment.
Plus thinking, right? So it's all of that, and especially sociology is very important today. You know, with all this data that is available there on social networks. So that's very important. So it's a combination of all these disciplines, not only statistics, informatics, and computing. Communication is also very, very important. Thank you. Let me see. I think I can go back to that one. Remember that equation. And it's more than just analysis. Let's see. And I think this is very important. To perform the data science, one in the core, in the center of data science is what we call the data life cycle. So it's all the process that you follow when you involve with the process involved with manipulating data. Okay, so let me see who else can help me. Who can help me explain this chart? There are several ways to present this. One of the data scientists there, was it? Who said that it was a data scientist? Oh, Sergio. No, who was the last? Juan Sebastian Vargas, was it? The last student?
Yeah. Yes.
Yes. You said you had to do some data analysis or something like that, right?
Yes, data engineering.
Data engineering. So can you help everybody understand this data life cycle and where it starts? Does it start here?
No. Let me see. Collection.
Okay.
Collection. Yeah. Where you start to gather data. Okay, but let me see here because I'm a little bit confused on some steps here.
Just focus on the big blocks here.
Okay, but would you like me to explain or to read? Sorry.
To explain, of course.
Okay.
Data engineer.
Okay, you're challenging me. Okay. So, collect. I would say that first collection is the first because it's where you start to gather data.
Okay.
Mm-hmm. I'm not quite sure about access. Because it says auditing. Maybe you can start to make tests on it on top of the collection of data. So that could be like that in that part. In the usage, I would assume that you're already like building dashboards on top of it, but then you get storage. Because that's the thing. I'm not quite understanding the flow of this specific chart. Like
maybe this one.
Maybe that one. Yeah. Data preservation. Data reuse, data access. Okay.
This is more clear, right? Maybe.
Yeah.
And this is just to challenge you and everyone, is because there are several ways to present the data life cycle. Okay. I think this is more clear. And let's show you a couple of charts tomorrow.
Yeah, that's true. So
Okay.
yeah, maybe you would say that you start on data creation, perhaps.
Data creation, okay.
Yeah, data creation, and then you start what I did say earlier about processing it, like removing values or changing some bits of it, and from there you start to analyze it, which is where you can build insights. And preservation, I don't know if that like counts for I don't know, historical data or kind of having like backup data, like you'll having the like all your data already gathered.
Okay.
So then you can perhaps access whatever your inquiry wants and reuse it. It's like when they use when they compare statistics where they're analyzing the past, that can be added to that too. I would guess.
Okay.
Mm-hmm.
Thank you, Juan. Somebody else? Can somebody else me help? This is another way to show the data life cycle by IBM. This is a model by IBM. Somebody else, please. Hello. Volunteer. It's the same, but just maybe creating the stages are named maybe a little bit different. Hello. Nobody. Then I'll call someone. One of the manuals, Manuel, maybe Peña or Aponte, any of you guys? I remember you mentioned something about data scientists or something.
Okay, thank you. I could try to address it. So I think that first there is an important question behind this that is like the business problem or like the context problem. And after that, we had some data created. That could be the first step. And after the data is created, like in multiple sources, we have to join that data to use that data to maybe create some machine learning model or create some BI dashboards. And after that, we have to update our conclusion or try to make some insights about that information. But a very important step is that each time that we recollect or gather information or make some insights, is important to write that insights or to store what we understand about the problem. And after that, it's important to continue with the cycle, because every time that we understand something, we have to start again. So I think that that's the reason, because that is a circle and maybe it's not like a line.
Manuel, and what about this one? You skipped this one, I think.
Okay. Maybe that is, for example, if we create, for example, a machine learning model, it's important to make it available for other people, that the other people could use it.
Wait, I think I'm confused. How do you understand this pose? How do you understand this?
Okay, maybe I don't understand completely. I think
Okay,
that maybe could make something available, but I don't know.
Can somebody help him and everyone? What does this pose mean? One Ramos?
Yeah, I think that dispose means to discard or kind of destroy, but yeah,
Yes.
something like that.
Yes.
And the thing is that it's very important, because I think that there are a lot of laws that are related to that. Because, for example, there is this law in the CCPA in California that if you want to be, it's the right to forget, something like that. So maybe you want that your data is not going to be used anymore. So in that case, all the companies that have your data must forget and dispose all that information.
Yes, thank you. Yes, and this is actually the ones that I've shown. Thank you, Juan, and thank you. I once there was speaking, Juan Manuel as well. So this is from a perspective of of a data manager, you know, because even, you know, Manuel mentioned, and it's somehow hidden here because it's collecting the data for the company. But when you perform some particular process, then, as you mentioned, Manuel, very intelligent, very smart, intelligent, your contribution there is that you need to start with posting a problem, a question, and then from that you start, you know, collecting the data or organizing them, and then performing the analysis and see the insights that you get from the data. But this is more from a perspective of the data manager. This is another way to put it, like this is in the context of research, you know, same as Manuel said. First of all, you need to plan the research, to collect the data, you process and analyze the data, and this is actually very common for those who perform research. Perform a process and analyze the data, you publish and share the data, you present the data, and if possible, you reuse your data. And this is very common in research, that you reuse the data to perform other types of analysis. This is also in the context of research. You propose a problem, you collect the data, you ensure the quality, you describe, you submit, you present, you discover, you integrate, you analyze, and at the end, you publish a paper. And this is one of the most maybe complete that I like. And this is for Texas A&M Transportation Institute. And I like this one because it not only talks about the technical process, but maybe other aspects that need to be taken care of or taken into account. Let me see, who can help me maybe get some explanation about this chart? Again, the way you understand it, please. And feel free to just contribute and talk. Anybody? Hello? Everybody? I'm so sad if you don't talk. I'm gonna cry. Juan Ramos, please, you again.
Okay. So what I understand is that first we are collecting the data. So there, then once you have the data collected, you have to process. And there they mention techniques and data quality metrics. I think that just to ensure that the data, yeah, it had some quality. Then you have to store and secure. I think that's very important to make sure. I think that it was mentioned in a previous slide that some information we have to encrypt it when it's in transit and at rest. And once we have that, once we secure that data, we have to use it. Let me see. Yeah, and after that, once you use, you have to communicate. I think that once you have this information and once you get some insights, you have to, as this mentioned, share and communicate with the stakeholders. And after that, you have to store it. Yeah, you have to archive all the data that you need and you may need later.
And what are the two last roads, paths that you can follow?
Yeah, you can reuse that information or you can destroy.
Okay, maybe let me just, I will need to maybe zoom it in a little bit. A couple of things that I would like to address. This is from the perspective of the data manager, right? So this is from the data manager's perspective. Before I give you the floor, Juan, I would like to address that the use refers, in this case, Juan, what does it refer to? Juan Ramos? What do you refer to as use in this case?
Okay, as use, it seems like, let me see.
Performing the analytics.
Information, maybe.
Analytics, performing the analytics, right? Like use is getting the insights from the data for some purpose in the company, right? Or whatever the context is, right?
Right.
One, Sebastian, you were going to say something, right?
Yes, maybe I can complement a little bit better here.
Go ahead.
My teammate. Yeah, well, okay. So in collect, for instance, like it says procurement and partnership and starting to see how to get data. So in the project I participated on, we were kind of having problems to get some HR data. Let's say, I don't know, like the pay slips data, for instance. It'll get into a process and all that. And when you get it finally, because you need it, because you already have like the project going on, you start to process it, as it says there, and then in the process you start to sort it and process it. It depends on the paradigm. It could be an ETL pipeline, right? So process and storage, you have to take into account how much does it cost and all that. And then exactly as Juan said, you start to make analytics on it, because you need to see what you want to measure. Maybe people are being, maybe people are dropping positions, like they are renunciar. I forget the name. Sorry. They're resigning their jobs because they're not paying well. So you need that data to start analyzing on that. But you need to think which parameters, they call it KPIs, indicators, performance indicators, that kind of thing. That's where this goes, basically. And then sharing means, for instance, in that project, meant to publish dashboards in a cloud. In that case, it was Tableau Cloud, for instance. And then, of course, we have an archive, and the archive has its costs, because if you're storing that in AWS, for instance, it'll cost something. So you have to have a budget for that too. And later on, I realized too that we will prompt to destroy data because of policies, because data cannot be stored like more than, I don't know, 5 years, because there's a policy about data privacy and all that. So yeah, that's what I wanted to add.
None of you guys mentioned one very important reason, and it's happening at a university. I'm sure you know the universities as well, that sometimes you need to destroy the data is because you don't have space to keep it. Is, of course, there are some rules to they mandate you that you need to store the data for certain time, but at some point you say, you know what, I cannot store more information. I will need to destroy some of that data. Okay. Let me see. Somebody else was going to say something.
Okay, thank you, teacher. I would like to understand more the destroy process, because I know that destroy information could be very dangerous. And for example, if information is like 10 years old and maybe in that moment is not important, but maybe 15 years or 20 years will be that information important. So I don't know if destroy part is more like depend the context, or in what context could be important.
Yes. First of all, as they have mentioned, sometimes it's just about some laws that you need to comply with the laws. So if the law says you have to preserve them, no matter if it costs us whatever, you need to keep it, to store it. Sometimes it's because, you don't have the space, and then you need to, for technical reasons, you can destroy, but as long as you don't break the laws, because you need to preserve that information, and also some information that maybe is not useful anymore, that you consider that is not relevant, then you can also destroy it. Manuel, you were going to say something?
Yeah, I just like to add that there isn't always like a destruction, because the dispose of information is something reflected in let's say a logical deletion, not a physical deletion. So the information is moved to a data warehouse or something like this. So the information, as you said, if after 15 years is required, is somewhere, but it is not in the main server, let's say, like taking that space and taking that processing unit. So the disposable information can be physical or logical, depending on the politics, let's say.
Yeah, but still, sometimes the data just die, as you mentioned. So you need to ask and and check with the
Yeah.
company when the data actually will die. And just to complete this, and this is very complex, the whole data management process, and you need to keep take into account as a data manager, the laws, policies, liability, ownership, because as one was saying, especially nowadays, you collect information with your partners, your stakeholders, and then it's important who is liable, who is responsible, who has the responsibility to keep the data secure. So who is the owner of the data as well? What is the purpose and value of the data, the public process, the security, and also to maintain the data some quality standards. Okay, let me just continue. Let me see. I think this is the time where so big data is not the same as data science, So the big data refers to big volumes of data. It refers more to the technologies that came out, to collect the data and maybe to perform some processes. But data science is more about the methods to analyze this big data available over there, So it's more technical than scientific. And also, who was the one who mentioned the BI here? I think some of you guys will work as business intelligence guys, right? One of you mentioned that. That was a term that was used to.
Yes.
Was used. Was it you?
Yes. Yes. I work with business intelligence.
So, but business intelligence, the main difference is that you query about the past, but data science is more about query about the present and the future. And you mentioned somebody mentioned the data warehouses. You store information about what was the past for the company, but data science is more about inquiring about the present and also what's going to happen in the future. That's the main difference. And also machine learning is just some methods that help data science get insights about the data. That's also very important. This. Stephanie, can you help me read? Because this is very important. By the way, today yes, we are going to give you a first assignment on this section, What is a data product?
A data product is a deliverable from data, or is enabled or driven by data and can be discovered, prediction, service, recommendation, decision making, insight, thinking, model, mode, paradigm, tool, or system. The ultimate data products of value are knowledge, intelligence, wisdom, and decisions.
Okay, thank you. So think about, and part of the what you get from data science is come up with data products. So it's any product or any deliverable rather that comes from the data or is enabled by the data or driven by the data. It could be a discovery, a prediction, a service, a recommendation, decision-making insight, a thinking, a model, a mode, a paradigm, a tool, or system. Please, can anybody give me a couple of examples, one example of a data product? You use them every day, all the time. Give me an example. I hear you, I read you. Hello? Let me see, let me just switch. Dashboards, yeah, but be more specific, Stephanie. Can you give, there are many dashboards, but can you give a particular dashboard, Stephanie? For a company or in context, even if it is not your company, but other company?
Operation dashboard.
Operation, an operation.
An operation.
What type of operation, for example?
In the company I work, they capture data every day and they have to log in and demonstrate they are some specific hours in the store.
Thank you.
So
Yes, that's a good example. I will read the others so we can go faster. Ivan said, well, podcast, yes. Emmanuel said, recommendations that you get in YouTube. Let me see. Somebody raise your hand. Who was it? You can speak. Whoever raised your hand, just speak.
Yes, I have maybe example
Go
is
ahead.
the homepage of digital newspaper.
Oh, what? What new web page? A newspaper?
Maybe the homepage of the digital newspaper can be data product if the news items featured in the homepage and CR dynamically select based of the previous navigation data.
Okay, good. That's a good example. Another example. Thank you. Who was it? Sorry, I didn't get your name. Who was the one? The lady who spoke? The girl? Laura. There are several Lauras. I'm sorry. I will have to get used to your voices to speak
Okay.
to each other because I don't know which one it will. We have several Lauras here in the class. The Google search engine. Santiago says it's some diagnosis based on the data from the patients, for example, in medicine. Yes. Yes, Ivan said ChatGPT, the whole ChatGPT that is a data product based on a lot of data. Let me see. Paulo, you raise your hand, open your mic, speak. Paulo.
Hi, Profe. Well, I was experienced with the electrical sector because I was working with in a central control. In this part or this area of this sector, management a big software called SCADA because the SCADA is very important in this sector because acquire in real time a lot of information in real time of the several sensors.
Okay.
Okay.
Yeah, finish. Sorry, I just interrupted you. Is that complete?
No, the idea that is introduction is
Okay, that's good.
that you can do.
Okay, so and the data science is in the middle of all of this. I think you recognize this, though this is not in place anymore, right? So it's X now. But anyways, can anybody help me? Why this is if you're familiar with Waze, why is this a data product? Can you develop somebody? Give me the explanation. Why? Anybody? Has anybody used or knows what Waze is about? Hello? Whoever raise your hand because I cannot see. Oh, Manu.
Okay, thank you.
Manu, go ahead, Manu.
Waze has a service that performs best path from point A to point B. So that is an internal algorithm, but that algorithm is consumed from a web page or from a mobile application. So that is application, and that's an data product because based on data, that data is being used for some users.
Good, very good. Thank you, Manuel. Okay, and applications of data science, you name it, business analytics, social media, e-commerce, entertainment, healthcare, finance, manufacturing, transportation, and so on, So, and let me just, this is just a fast overview, and let me just post, sorry, stop presenting. I'm going to share a small video. It's a short video. I think yes, I just have the time to post to share it. I'm gonna play it. Listen now. I'm gonna play. Oh no. You see this one? Yes, this is it. Okay, I think now the audio is okay. So I'm gonna play it.
Welcome back. So we're talking about data science, this kind of intro overview of data science. And I've really emphasized that this is about asking questions and then questions that you can answer with data, and this being a feedback cycle. So we're going to start to talk about what questions you can ask and get into a little bit more detail soon. I want to talk a little bit about the data for now, kind of the various things we'll do with data. A lot of data science goes into collecting the data, storing the data, cleaning the data, processing the data. So collecting, curating, storing, cleaning the data are huge aspects of data science. So a lot of database engineering and management, a lot of data processing algorithms, cleaning data, identifying outliers, and filling them in. What if you have missing data? Real world data is messy. And so the collecting, curating, and cleaning of data is absolutely critical. I should probably also say part of this feedback is identifying the right data to start answering these questions. So you have to identify, do you have the data? Can you get the data? And then start collecting, curating, and cleaning that data. Okay, so this is kind of database engineering. And then what you want to do downstream of that are things like visualize. So you want to visualize. You want to analyze. And you might want to model, build models for prediction. You might want to build models that can be used and deployed in the real world. This is kind of where machine learning comes in. So machine learning is super exciting. Lots of interest in developing these models from data, but you have to go through all of this hard work first. So tons and tons of effort here to get to I don't know, for me, I really like visualizing, the fun part of visualizing, analyzing, and modeling. This is interesting and fun too, but this is kind of, goes in this direction. And there's feedback though at every step. Once you visualize the data you've been collecting, you might decide that you need to modify your data collection or the way that you're storing or to ask different questions. Once you start analyzing and modeling, again, there might be feedback loops at all levels of this process. So this is not kind of a static architecture. This is a dynamic process, again, in the hands of expert humans, teams of humans asking questions that can be answered with data. So I think of data science as kind of data-driven inquiry, or the science of how to do that data-driven inquiry. And I'll be blunt. A lot of times when I talk to companies, for example, in consulting, they spend a lot of time and effort, a majority of their time and effort in this side, in this kind of data engineering. And I've heard all kinds of analogies and stories. You're going to build a data lake, and you're going to have all these data rivers going into data lake, this big warehouse where you're going to hold all of your data. And I must caution you, if you don't invest in the analysis, the modeling, the visualization, you're going to find yourself up data creek without data paddle. Okay, so you need to do this. This is critical, but you also need to be investing in kind of the analytics and the modeling and these rich things you can do with your data. And I think visualization is so important because we're inherently visual beings, and this visualization also is all about communication. So if you have a great idea, but you can't communicate it to your boss or to your team, it wasn't that great of an idea. And so visualization is also a critical aspect of how this feedback cycle works. And that's another kind of point I want to make, is that data science is not about the data. It's not about the algorithms. It's about the people and the teams and the problems you're going to solve. It's questions you're asking. It's problems you want to solve, problem solving. And it's an inherently collaborative art. So data science involves teams of people collaborating. So teams of experts. And in the traditional model of an expert, you might have, we call these T-shaped people. So you have some breadth, not just one thing, but lots of things, and you have a lot of depth in one area. Maybe this depth is in designing, automotive, aerodynamic streamlined bodies, or maybe this is in aircraft design or space mission design, or whatever it is that you're interested that you do. For me, it's fluid flow control and fluid modeling. But increasingly what we're going to find in the future in these teams of data scientists, or sorry, data scientists on teams, problem-solving teams, is that people will need to develop a second depth area in data science. So this is what people call pie-shaped people, pie-shaped experts. So you still need your breadth and your domain expertise, but now you have this kind of data science expertise. And so I really want to emphasize data scientists are not just going to be sitting across a firewall from the people collecting the data and solving the problems. You want data scientists on your team in the room helping you make decisions. In fact, ideally, you want the experts who are collecting the data and doing the problem solving to have data science expertise. So this is going to be like computer literacy. You don't just have everybody who solves problems and then people who only a few people who understand how computers work and a firewall. You have your team of expert problem solvers and they all have a basic degree of computer literacy. And then you have kind of experts who are on the team. Okay, and that's how we see kind of data science evolving, is being a core functionality that your whole team, you're gonna have to integrate this into your team. Okay, other things that are really important are these aspects of reproducibility. In science, there has been a crisis that lots of results that have been published, when other groups of scientists try to reproduce them, they can't. And that means there's something wrong in the way that we are conducting and conveying scientific data. And so this idea of reproducibility is really ubiquitous. We want the processes that we spend our lives developing and improving to be reproducible by others. We want reliability of the things we learn and the things we optimize and design. And so reproducibility is also critical in data science. How do you collect enough data that your processes are reproducible, that you have standards in some sense? Okay, so lots of things to think about. It's about this feedback. You have to do a lot of work collecting your data and curating and cleaning, but then you get to analyze and visualize and communicate. You get to solve problems with data on teams. And hopefully your teams of experts are not kind of segregated into domain experts and data scientists, but you have people who have this kind of mixed capability of domain expertise and data science expertise. Okay, we're gonna keep.
Okay, so it's about answering questions. So that's why it's very important that you answer questions regarding your company or your particular context to solve a particular problem. So I would like to address maybe in the couple of minutes that I have left today, but maybe Professor, I would like to take a few minutes at the beginning of the next session, since today, because we introduced the students and all that took a lot of time. To wrap up some things regarding data science. So what we usually have done in the past, traditionally, when it comes to data analysis, is what we call this explicit analytics. And he mentioned something in the video, is about some information that is on the surface, that it may be easy to find, like, for example, if I'm not going to ask your ages here, but if I ask your ages, and then maybe I perform some statistical analysis basics, just take the mean, maybe the mean and the standard deviation. I would say the average of the ages of the students in the class, the average age of the students in the class is, give me a number, by the way. I read you. What would be the average age of you guys? So that's maybe easy to find. Oh, not that old. No, I think you're just like teenagers. But anyways, so it's more about what you see in this chart, what we call implicit analytics, that is there at the bottom, and you need to dig deep to find that information that is hard to find. Okay, so that's what we call implicit analytics, and that's what is the main interest of data analysis. And another point that I wanted to make just to wrap up today, is that you need to visualize the information. You need to communicate the results of your insights or your analysis. And that's in the equation. Remember, communication is very important. And this goes especially to everybody, but especially to this student who said that he wanted to work on his own. And he mentioned, you need to work in teams in data science. You need to communicate the insights of your ideas. So that's very important, communication. And one way to present the results of your insight is using charts. There are many ways to present the results of your analysis. There are some popular charts, just as bar plots, Pareto charts, pie charts, word clouds, see, maybe histograms, box plots, here they are, QQ plots, let me see, correlation charts, heat maps, and so on. So you need to communicate the results of your analysis in a graphical manner. Okay, so time is over today. We are going to give you a first assignment, which is related to look for a data set, and you're going to work in teams. We're going to assign the teams, and you need to answer some particular questions on that, based on that data set. Okay, so that's the first activity. And identify the data lifecycle for the associated to that particular data set. You will ask some questions. You will post some questions about the data that could be answered for the data. You will perform some basic analysis, just exploratory data analysis at least, based on that data. And at the end, also, you will think about a particular data product that could be developed from that particular data set. Okay? This is already stated, planned. So what I'm going to do is tomorrow, I'm going to send you the files. And also, I think by tomorrow, we're going to add you to Classroom. And there you can ask any questions about the assignment, okay? And we took 2 more minutes. I'm sorry about that. But don't worry. So it's important that you start working on collecting data and performing some basic analysis, because later on in the class, we'll need to do that. This is going to be a simple analysis, so no worries about that. It's going to be just some basic statistics, applying some statistics. Ivan?
Yeah, so then you are deciding the teams, or?
Yes, we are.
Okay.
This is for this first assignment is going to be a random, actually. Okay, it's going to be a random.
Proper.
But later on for the project, we are going to make up the teams. Okay. The average, let me see. I was reading 25, 31. I think 31 is too much, too high. But anyways, so maybe Sebastian said 27. Okay. So we'll give you the directions, the instructions rather, to make the assignment, okay? To do the assignment rather, okay? So, Professor, are you still there? Sorry, we kept you a couple of minutes late.
Yes, I'm here.
So just
see you next week, guys. See you next week.
See you next week, and thank you. I hope this excites you. We are very excited about this class, and we are very happy to have you here in the class. Okay, I hope you guys enjoy the class as we do. Have a nice evening. Okay, I'm going to stop the recording. This is very exciting.
Thank you. Goodbye.
Bye.
Bye.
Now you guys here is very exciting.
Bye.
I promise. Bye.